starting this review with limits. So I give you some highlights on limits here. The first thing that you're going to do if you have limits approaching a number is you're going to plug in. If you get a number, great, that's your answer. If you get 0 over 0, you're going to do more work. And if you get a number over 0, that means you have either an answer of positive, negative infinity, or does not exist. Now, if your limit is approaching positive or negative infinity, that's when you use your exponent rules. And then, of course, you see there if you have a piecewise function. So read through those. I think they'll really help you on your final exam. Okay, so remember, if you have a limit that's approaching a number, all you're going to do is plug in. So we're going to say 6x squared minus 4x minus 6. The number that I'm plugging in is 6. So that's going to be 6 times 36 minus 24 minus 6. And when I put all of that into my calculator, I get 186. So that's my answer. Will you have some like that on your exam? Yes, you will. Just plug in and get the answer. Okay, so here's another one. We'll just plug in. My value is 1. Let's plug in 1. 7 times 1 squared minus 9 times 1 plus 2 over 1 squared minus 1. When I plug in on the top, I get 7 minus 9 plus 2, so that gives me 0. When I plug in on the bottom, I get 1 minus 1, so that gives me 0. 0 over 0 is not an answer of 0. If you get 0 over 0, that means do more work. Okay, so the do more work that you do is just to factor. So we're going to take the limit as x approaches 1 of 7x squared minus 9x plus 2 over x squared minus 1. When I factor that, we're going to use trial and error. You can also use bottoms up for those of you familiar with that. When I plug these in, I get a 7x and a 2x. So that would give me a 9x. They're the same sign, both negative. The bottom is the difference of squares, x minus 1 and x plus 1. Your x minus 1s cancel out. So you're going to take the limit as x approaches 1 of 7x minus 2 over x plus 1. Okay, once you get there, you can plug in your 1. So you get 7 times 1 minus 2, and that's over 1 plus 1. 7 minus 2 is 5, and 1 plus 1 is 2. So my answer for this limit is 5/2. Okay, now it's kind of tricky with these multiple choice possibilities. Remember that 0 over 0 means do more work. It doesn't mean 0. Okay, you have 0 in the bottom, so it's easy to think, oh, that would be does not exist. But it's also does not exist because you were doing more work. So make sure that you don't fall for the tricks that they put in the multiple choice lineup. Okay, here we have another one. We're going to plug in 5. It's just a number, so when you have a limit approaching a number, just plug it in and see what happens. When I plug in 5, I get 5 minus 8 over 5 minus 5. So that gives me negative 3 over 0. Now a number over 0 means that you're either going to have positive infinity, negative infinity, or does not exist. That means as we approach 5, the graph is either going straight up or straight down. In a one-sided limit, as this one is, you don't have to worry about them matching because you're only looking at one side of it. So what we will do in this possibility is it's got to either be positive or negative infinity. Okay, so it's one of the two that are left. The way that we pick which one it is we're going to plug in something on this side of 5. So something on this side of 5 would be 6. So we're going to plug in 6 to determine the sign. Okay, when I plug in 6, I get 6 minus 8, 5 minus 6. That's a negative 2 over a negative 1, and two negatives make a positive 2. Do not pick this as your answer. See, it was one of our multiple choice ones. Do not pick it. All that I'm worried about right here is that it's positive. Since it's positive, that means my graph is going up. And since my graph is going up, positive infinity is the answer. Okay. Now sometimes, as you see on the screen here, the negative is very small. So make sure you don't choose the negative infinity. Be very careful and very diligent in making very good choices with your multiple choice. Negative infinity is also not an answer. Okay, so basically that's how limits work if you're plugging in a number. But what happens if you have limits at infinity? Well, they are very easy. You just have to remember your 3 rules. The 3 rules are, if your highest exponent is on the top, let me write that out a little bit. Let's see if I wrote it somewhere. Okay, I didn't, unfortunately. But if your highest exponent is on the top, the limit is either positive infinity or negative infinity. Do more work. If the highest exponent is on the bottom, your limit is 0. Easy enough. And if your highest exponents are the same, you use coefficients. When I look at the problem on the screen, I see a power of 3 in the top and a power of 3 in the bottom. That means my powers are the same. So since the powers are the same, you're going to use coefficients. This coefficient is 6. This coefficient is negative 1. So my limit is negative 6. And that's how you do it. Let's look at the next one. When I look at this one, I see my higher power is on the bottom. If the higher power is on the bottom, your limit is 0. So this particular part, limits at infinity, is just a matter of memorizing the rules. Your last limit that you have is a piecewise function. All you do with a piecewise function is plug it in, both pieces, to see if it matches. I'm asking the limit as x approaches 5. If I plug 5 into the top, I get negative 15 plus 5. So I get negative 10. If I plug in 5 into the bottom, I get 31. Do these match? No. If they do not match, your answer is does not exist. That means they don't meet. And a limit, in order for a limit to exist, they have to meet. So since these do not match, the answer is does not exist. Let's say they did match. If they did match, whatever they match to would be your answer.